All right, let's get started. Before I go into the Mahia and things like that, I just want to refresh because you guys were asking. So everything that you need to worry about when it comes to class is posted on my Google Classroom. So do kind of keep that in mind. If we go under classwork, you can see that I have put the lessons in order. So 1, 2, 3, 4. And whenever I post the lesson, I note down what week you did or what week you should be doing that lesson in, what day that you did that lesson in, and then also the date. So if you weren't here in our previous lesson last week, this is the only one you have to worry about. It is the term 1, week 3. That was Tuesday's lesson. And so Tuesday last week, I believe, was the 15th. Cool. And then you should be able to click on the link to get to the lesson notes. I think there might be something wrong with this link, though, because I think you're doing the edit version. Yes, you are. So let me just view the published site and give you the right link on that. Copy that over and fix it. Let's see. Let's say that's for Tuesday, and this was on February 15th is when we did this lesson. Cool? Right. When you open up the link, it'll go to my Google site. So really, really easy then to catch up if you've missed a lesson. I have recorded the lessons. So if you want, you can watch exactly what we did in class and exactly how I explained it. The PowerPoint that I've used in class is also on there, but that's the stuff that's been printed in your booklets already. And then the other thing is I've included those Mahi choices, so you can choose which level you're at and what material you want to do then as your revision and practice. So when you guys go to start doing work, if you're doing any work remotely, you can find things here and you can choose what you want to work on. Does that sound good? Yep. And then don't forget, so I can see the work that you're doing. You should be putting it into UE grade evidence for structure and bonding. So I have given you guys a blank Google Doc. So if you're working from home and I want to be able to see what you're working on, you just type it in here. Cool? All right. Anything else? You guys good with that? You ready to, you know what you need to do if you want to go online? Think so? All right. I'm hoping it's pretty self-explanatory. If we are in remote learning mode, I will still record the lessons, but I'll just do shorter snippets to explain the different context. And then you guys can watch the video and then do the recommended work along with it. Or you can just jump right into the work if it's easier for you to do the work on paper. All right. So let's do today's lesson. So today, let's start off and let's have a little fun, blow off some steam. So we are doing some random questions and the micro goal. So random question for today was, if you could be best friends with a celebrity, who would it be and why? The person answering that question today is going to be James. You're going to go first. The Queen of England. She's got COVID. I don't want to be friends with her. Yeah, she does. Why would you want to be friends with the Queen of England? You can ask for money. I like it. Yeah, putting your friends up for money. All right, next person that's answering that question is going to be Charlie. Oh, I wouldn't have one because I've already got friends. You wouldn't have a celebrity best friend because you already have friends. You've hit your quota of friends. We are done making more friends. I love it. No, sorry, can't be friends with you. I've had my quota. Okay. Micro goal for the week. What are we hoping to accomplish? Person answering that today is going to be Cam. You can say your biology goals. It's the same goal. Focus class, yes. We have a lot of content to learn in science, unfortunately. Neil, I think I called on you in the last lesson too. Micro goal for this week. Wake up early. Yes, I remember you saying that. I like it. I'm a morning person. That's where I tend to think the best. All right. Anything you want to share? Yes, Ruben. You're the what? You guys are giving each other compliments. I love it. I guess my news is that I went to a wedding on the weekend. So that was really lovely. My partner's cousin was getting married, and we went up to Omaha, up north. This was a nice little beach weekend, so I got a nice little break. Yeah. Yes. Ruben looks very good. Ruben looks very good. Let's just trade the compliments back here. I love it. I love the positivity. All right. Cool. Let us switch gears. And with that switching of gears, we're thinking about our learning journey and what we are doing. So, in order to do that, we need to first think about what we were doing last week and how it's going to continue to build. So last week, we were looking at covalent networks. We were thinking about their physical properties that they have. And then, like always with these types of solid questions, we are going back to the atomic structure. We're thinking about the particles, and we're thinking about the bonds that are there. So, today, we're continuing on with that idea, but we're just doing it for a different type of solid. So in this case, we are doing the covalent molecular solid. So now we've covered 3 out of 4. So we're basically almost done. And then you guys will be able to answer a third of the exam for this topic. Just right here. All right, and then before I move on, just our weekly Nakatoki. So in this case, it is while the Bokara grub is small, it cuts through the white pine. AKA, there is power in small things. I would say, because I'm quite small, so I think it's power me. But you know, a couple of things add up and can have really big impact. And I'm glad you guys are doing small things like giving each other confidence. All right, cool. And the reason why is because I want to give you guys some chances to kind of digest the material I've talked about so far. So first off, we will start with the describe and explain. I think those are really good for whenever we're looking at a new type of solid. I will give you guys some notes, and then we'll wrap up, and you guys will basically have more or less a study period because you're going to have your multiple choice. Yeah? I think you guys need some time to digest, and I know that some of you guys are absent, so you can use it to catch up. Cool. All right. On our success criteria, we're looking at the second half of number 5. So if you look on that pink checklist, number 5 says I can explain the properties of covalent molecules, and I've crossed out the covalent networks. We did covalent networks last week, so we're doing covalent molecules this week, and it's the same properties that we are thinking about when we're looking at them. So we look at all the same properties, and we're tying it back to atomic structure to figure out why do they have those properties. We get so far. All right. Cool. So we're going to describe and explain. It is in your booklets. And what I've done is, in our booklets, not sure what page it's on. I should have numbered the pages, right? That would have been smart. There we go. So, this image here is the one we are looking at. And I want you guys to take a moment to describe what you see in that image and explain that image as well. I want you to think about the properties of covalent molecular solids. So some examples of that would be dry ice, which is that carbon dioxide, and water, aka ice. I'm going to go see if there's any ice in the freezer, and I'll leave a little bit of ice on your table. You can look at the ice and see if you can think about describing what the ice looks like and what properties it has, explaining why it has it. No, unfortunately, it's ice because it is a lab. I have no idea where this ice has been stored. It could have been stored next to organs and stuff for dissection. So I don't think you guys want to use that one. Yeah. All right. So I'm sure that we do not have a booklet. I don't have the page numbers on there. It's probably a slide number if that helps. Slide 26. Anybody else need a booklet because they didn't get one or they forgot theirs today? It is also on the Google Slides as well. Google Slides. Anybody else? I got one more. All right, let me go see if I can find you some ice. Describe and explain. All right. I heard some really good discussions and ideas. So, when we are describing and explaining, I think you guys need to do piece of ice. What's your reaction to the ice just sitting in this classroom? Melting. It started to melt, right? So we're thinking about the logic and a sequence of ideas. So melting suggests what characteristic? So looking at this list. It's turning into liquid, so it's telling it has a low melting point, right? And then Quinn is able to get the list of explaining why. So these are one of the reasons that has a low melting point. The intermolecular bonds are very weak. Yes. So if we think back to lesson 1, we talked about intramolecular and intermolecular bonds. Intra, remember traumatic, those are the bonds between the atoms. A lot of energy to break them because we're doing chemical changes. When we're talking about intermolecular bonds, those are ones between molecules, and they are very, very weak. So, very weak tells me not a lot of energy to break them. Not a lot of energy to break them. I don't need a very high melting point for that. So you can see that the ice is melting at room temperature, but if I gave you guys a paper clip, look at it next to it, would the paper clip melt? No, because the temperature is not high enough. We don't have enough energy to break the metallic bonds. Yeah. Thinking about those other properties, when you think about water, I accidentally dropped some of the ice on the ground. What happened? It cracked and shattered, right? So that's brittle. Again, we can tie that in to the intermolecular bonds. It doesn't take a lot of energy to break those bonds. So dropping on the ground is enough. Yes? Okay. Cool. Let's talk more about some molecules. So, here are some examples of molecules. The thing that's important to remember about a molecule is that it's only a few atoms. So they're not terribly big. The other thing to keep in mind with molecules is that they can be compounds or elements. So if it's a compound, we have two different elements. So I have most of those are examples of compounds. But ozone, for example, is a molecule that is an element. So when you guys are looking at this question, remember how I said at the very beginning, classifying this as a solid is key. If you misclassify and then you justify your answer, the whole thing gets marked wrong. Yeah? So we need to be really, really careful when we're classifying. So with the molecules, the first way I see a molecule is if I'm dealing with non-metal. Now it could be non-metal as a compound, like water. It could be non-metal as ozone. Yeah? The other thing to keep in mind is that both covalent networks and covalent molecular are going to be made up of non-metals. So we're going to read the rest of the question, and we're going to look for hints about their properties. The key one being about the melting and boiling point. So if I see anything, I read it, and it goes there's a very low melting and boiling point, or if it says something like it's a gas or liquid at room temperature, that hints to me it's a covalent molecule. That's the only one that'll do that. All right. Cool. So thinking about these forces and thinking what it's made up of. So molecular substances, the particles molecular are molecules. So when you put it in the table, the type of particle is the molecules. And they are separate molecules, but they can be packed together. So there's two forces that you keep in mind that's present. You guys learned about this in the first lesson. The first one are those intramolecular forces, and that is inside the molecule itself. And those will be covalent bonds. So that's why it's called covalent molecular. Covalent bonds are present in that molecule. However, with this type of solid, though, what is making a solid and what's also going to be broken when the solid is heated are these intermolecular forces. And we know previously that those intermolecular forces are very, very weak. So that gives these covalent molecular unique properties for their solid. Now, with these guys, you have to think in the solid form. So even though ice is a liquid at room temperature, you better used to dealing with water as a liquid. When we're thinking about these examples, you need to think about it in the ice form. Okay, we're thinking about it in the solid form. Are we good? Yep. Okay. Melting boiling point, very low in general because they have weak intermolecular forces. Keep in mind we have the sulfur as an example. The sulfur was a solid at room temperature, but you could easily heat that up and it will turn to a gas. So the strength of the intermolecular forces will determine its melting and boiling point. So some things to keep in mind. The larger the molecule or the larger the atom we're working with, the higher that melting and boiling point is. And that's because they have an increased number of intermolecular forces. That's mainly it. Yeah. So bigger molecules tend to have that. So if I was comparing carbon dioxide to iodine, iodine is a liquid at room temperature, and that's because it's a bigger atom. It's quite a chunky atom. If you look at it on the periodic table, it's all the way down here. So it's quite a big atom. You know, just the two of them. If you're thinking about carbon dioxide, it might be 3 atoms, but those atoms are at the top of the periodic table. It's not very heavy. So what are the physical properties? These guys tend to be liquid and gas at room temperature. That's going to be evident when you're reading the question you have covalent molecular. They are very brittle, and we saw that when I dropped the ice on the ground by accident. And that's because they have those weak intermolecular forces. It's very easy to break them down. Don't worry about copying that everything that I have there. Yeah, for the new people that just don't worry about madly writing down all these notes. It is in the booklet, and I have provided the PowerPoint on my Google site. So the booklet there, I'm going to drop the notes down onto the slide itself. It's okay. All right, solubility is the next thing. We will do a whole separate lesson on solubility, so don't worry if you don't quite understand. Solubility, in this case, we are thinking about can I mix those two substances together. When it comes to the covalent molecular, it really depends on the molecules that we are dealing with. So we're going to see molecules get classified as polar and non-polar, and that's going to decide if it's soluble or not. It also depends on the strength of those intermolecular forces. So how strong are those forces together? Again, what's the attraction to self versus the other substance? In this case, polar substances will dissolve polar. So when we think about polar, we think about water. So anything else that's also like water and polar, it will dissolve. Non-polar will dissolve non-polar. So oil is an example of something that's non-polar. So if you have two oily substances, they will mix together. The other way to remember it is like with like. So if I mix water with oil, they wouldn't mix together. Now, both of those are examples of covalent molecular. I'll show you guys some examples when we start doing some questions. But like I said, we'll do a whole separate lesson on solubility. Cool. I think that's all I want to say. All right. The water on its own is not conductive. Yes. Okay, the thing that makes water conductive is stuff like salts being added to it. Oh. Yeah? So if I have pure water, and you guys will do an experiment later this week to test it, it's not going to be conductive. You need to mix in a salt to be able for it to work. Oh. So that's why when we think about water, we think about it conducting electricity, and they say get out of the ocean, get out of the pool. You shouldn't swim during a lightning storm. It's because there's stuff mixed into that water. Yeah? If we're swimming in the water, our salts in our skin is going to get mixed in there. If you're swimming in the ocean, that also has salty water. So that's why that's conductive. But if you're going to see, just tap water itself isn't actually conductive. All right, I'm good with that so far. So that is a common misconception. And like I said, you'll see the difference when we do our experiment. All right, cool. That's all my notes for today. Makes it nice and easy. I figured you guys would need some time to digest what I've talked about. And so what I have here is our monkey choice. Just pause my recording real quick. All right. So just to recap, we have explained and explored the physical properties of the covalent molecular solids. Do you guys want me? So here are the two choices. We can either move on to new content in the next lesson and do the ionic solids, and then you. Oh no, sorry, ionic solids aren't for a while. I want to do more molecules. All right, never mind. Next period, do you guys want as it's just a study period, just to kind of catch up with the work so far and process it? Okay, that's good. You guys have your last period, so we're going to wipe down the tables and put up the chairs. Success activity.